suppose that we have a cylinder and then we have a rectangular block, all the length is detailed out, and they are saying that the volume is given as 27. We have to express y in terms of x. So there are two volume involved here. The first one is the cylinder, and we know this is going to be pi r squared h, and then for this is base times length times by height. So the down one is easy. You're going to get 4x cubed, and then this one pi x squared y. Okay, so let's put that together. The next one, they said we have to find the total surface area, and the expression is given. I think the surface area, let's look at the cylinder first. I have a circle here, so when I open up this, I'm going to get something like a rectangle, and then the upper part is a circle. You don't include the down one because it's like an overlap, so that part is hidden. So let's look at this one. So if I open this circumference, it's exactly this portion here. So I know that this is 2 pi r and your height is the y. So let's write for that. So I'm having pi r squared. So the radius is x now, pi x squared plus 2 pi xy. So this is the area, surface area for the cylinder, added with the what is that, a block, the block over there. What is the area of this portion? 2x squared, and I have 4 of that. And then now let's look at the base, the bottom one. So the bottom one is 2x multiplied with 2x, so we are getting 4x squared. And then I realize I have this tiny bit over here, so this portion, they are still exposed, right? How do I find this one? So if you want to find that, you take the area of that square, which is 4x squared, then you minus the area of the circle. So that will give us 4x squared minus pi x squared. So we put all of this together and see what we are getting. I'm taking this. This is 12, right? And then 4x squared minus pi x squared. This 2 gets cancelled. Okay, we are done. But now when I see that here a is being expressed in terms of x only, so let's get rid of the y substitution. Okay, then let's go to the question now. Now they are saying, hey, can you please go and find the value of the x for which a has a stationary value. So the keyword here is the stationary value. So what happens at stationary point? You know the gradient has to be 0. I have my a over here, and a is having the stationary value. So what we're going to do now, we're going to take the a and we're going to differentiate, and we will differentiate with respect to the variable itself, which is the x, and it has to be 0. So the x is 1.5 centimeter. So the moment you know the x value, try to make sense to the question. This is 1.5, and you're going to get a 3 here, 3 here, and you can find the y by substituting. Okay, now let's go to part B. In part B, they say find the value of A itself and the Y, okay, to this value of the X. So this is just mere substitution. I think you can do it. Substitute into the expression of the A. It's 18 and so that's our area. And what is our Y value? Where is the expression for the Y? This is expressed in terms of pi to make it look nice, but if you want to put it in decimal, it's 1.91 centimeter. Okay, then the next part says determine whether the stationary value of A is a maximum or a minimum. So for this particular X value of 1.5, am I getting the area to be maximum or minimum? So if you want to check the nature, then you have to do the second derivative. So you continue from here. So how are we writing that? 54x power negative 2. Then you multiply. When I put a positive value, when I put 1.5 into this to check, it's definitely more than 0. Therefore, area is minimum.